All right, so here we go. Here's all about trig ratios. Trigonometric is the fancy word for triangle. And it's triangle ratios, and we have three of them we're going to learn about. Sine, cosine, and tangent. And each of these are a unit ratio where we're going to compare the relationships between sides to 1, just like we did on our warm-up, where we were able to come up with a decimal value that represents these ratios that we wrote. All right, so our sine is going to be the ratio of the side opposite an angle to the hypotenuse. So the most important thing here is that we learn to name whichever angle we are talking about, and frequently they like to use the Greek letter theta. A little circle with a squiggly line through it counts as our theta. Once we know what our theta is, then it makes it easier for us to say which side is opposite and which side is adjacent or right next to. So here's my adjacent side, here's my opposite side if this is my theta. The sine is going to be the ratio of the side opposite to the hypotenuse. Your cosine is the ratio of the adjacent side to the hypotenuse. Our third ratio is going to be called tangent, and that is the ratio of the opposite side to the adjacent side. And now sine, cosine, and tangent are words that trace way back. There's really no definitive reason why we call them that. There's a little bit of a folktale where there was a mistranslation and the names kind of came about by accident. Whatever the case may be, we go ahead and they stuck, and those are the words that we use. We can abbreviate and remember these relationships by sine is opposite to hypotenuse, cosine adjacent to hypotenuse, tangent opposite to adjacent. A lot of times you'll see them written out as a silly phrase, so ka toa. There's all kinds of funny stories math teachers tell about an ancient Indian tribe, the Sokotoas and the right triangles, and you can Google that and be entertained by all of those stories. I got to tell you, I'm a lousy speller, so when I try to do Sokotoa, I end up sometimes twisting myself up. So I remember some old hippie caught another hippie tripping on acid. So that's how I keep my trig ratios straight. If you're a Post-it friend, then this is definitely going to be one of those Post-its that you make so that while you are working on your triangle ratios, you can remember your relationships between your sine, cosine, and tangent of each of these right triangles. All right, let me show you how this works. When we are given a right triangle, PQ or PRQ, if they ask us to find the sine, cosine, and tangent, they need to first tell us which angle we're talking about. So if P is our theta, then our sine is going to be our side opposite compared to the hypotenuse. So my side opposite is going to be 15. My hypotenuse is 17. If I want to know the ratio of those two sides for this angle, taking this value, and I can even go ahead and divide it, 15 divided by 17, I know that that unit ratio, think back to when we're buying yogurt or ketchup, or this unit ratio will help us solve that. We always round our trig ratios to the nearest to 4 decimal places. So I go out 5 decimal places, and then I round up if I see a 5, 6, 7, 8, or 9. So when I talk about the relationship between the opposite and hypotenuse, 15/7 tells me what the story is for this triangle, but this is the unit ratio that is going to apply to any triangle that has that theta. All right, let's talk about our cosine. So our cosine is going to be our side adjacent compared to my hypotenuse. And our tangent is going to be our side opposite compared to our adjacent. Your tangent is going to be the only ratio that ends up being greater than 1 because it doesn't have the largest side always in the denominator. So think about that a little bit. If Q is my theta, then notice my side opposite is different. So my sine here is 8/17. My cosine is going to be my side adjacent compared to the hypotenuse. And my tangent is going to be my side opposite compared to my adjacent. Now there's some interesting patterns here. Do you see how the sine and cosine of complementary angles are the same? Do you see how my tangents of complementary angles are going to be reciprocals? So here's what's kind of cool. We can use these ratios every single time to solve for missing sides and angles in right triangles, and they have to be right triangles. These ratios only work if I have a right triangle. All right. I can write each of these ratios as a unit ratio. So I started up here with 0.8824, and of course, I know that this decimal value will be the same. If I want to divide 8/17, that's going to give me 0.4706. And guess what? That's going to be the same for here. Our tangent of angle P is going to be 15 divided by 8. So that's going to be 1.875. And 8 divided by 15 is going to give me this decimal value, 0.5333. So these end up being our unit ratios. So let's consider this next question. Wouldn't it be neat if there was a list of these ratios for every possible angle measure? And if there was, could we find the measures of the angles? So I don't know if you've seen this yet or not, but as part of the notes, here it is. Here is a trigonometric table. And what mathematicians did was they measured every single possible angle of a right triangle, and then they calculated the sine, cosine, and tangent unit ratios. So if we wanted to, we could find what is our measure of angle P. I need a sine value of 0.8824. So let's look down my sine column, 0.8824. I'm going to have to come all the way over to here, 0.8824. This looks like it's as close as it gets, which means, and we're going to go ahead and round our angles to the nearest whole value. So check it out. My sine, 0.8824, pretty close. My cosine, 0.4695, round up to 0.47. Yep, that sounds about right. And our tangent, 1.875. Yep, that's pretty close. So if you're going to use these charts, there is an element of rounding, but I know that angle P is a 62-degree angle. Two ways I can find Q. I can go ahead and subtract 62 from 90, and I can say, okay, angle Q is a 28-degree angle, or I can go ahead and find a sine of 0.47, and there's my value for my sine, 0.47. So I know that the sine and cosine values are going to help me find, and these ratios are going to help me find these angles. So how can we use these ratios? I can solve for a missing side by getting the unit ratio. I can solve for the missing angle by using that ratio in my chart. All right, we're going to do some practice. Are you ready?